Albert Einstein was born on March 14, 1879, in the German city of Ulm. His father, Hermann Einstein, was an electrical engineer, and his mother, Pauline, was a housewife with a deep interest in music. Einstein was noted as a quiet and introverted child. Throughout his school life, teachers thought he was slow and uninterested in his lessons. However, this perception was wrong, as Einstein began thinking abstractly at an early age, teaching himself important mathematical and physical concepts. One of his earliest inspirations came from a compass his father gave him. Einstein was fascinated by how magnetic fields influence the needle, sparking his interest in science. His talent in mathematics and physics soon shone through in his education. He attended the Zurich Polytechnic School, ETH Zurich, where he studied mathematics and physics. However, he always had a difficult relationship with the education system, clashing with authoritarian teachers and often criticizing the system for stifling creative thinking. The year 1905 marked a turning point in Einstein's scientific career. That year, he published four groundbreaking papers that revolutionized modern physics. One of these papers explained the photoelectric effect, for which he would be awarded the Nobel Prize in Physics in 1921. His other papers focused on Brownian motion, special relativity, and the famous mass-energy equivalence formula E=mc². With these achievements, Einstein quickly gained recognition in the scientific community, and his fame grew over the following years. The four papers Einstein published in 1905 solidified his place in the scientific world. His theory of special relativity, in particular, challenged the limits of classical Newtonian mechanics and paved the way for modern physics. This theory demonstrated that time, distance, and mass change for objects moving at speeds close to the speed of light. Additionally, the equation E=mc² suggested that mass could be converted into energy, laying the foundation for technologies such as nuclear energy and the atomic bomb. Einstein's achievements were not limited to physics. In 1921, he was awarded the Nobel Prize in Physics for explaining the photoelectric effect. This discovery was a breakthrough that challenged classical physics and contributed to the foundations of quantum mechanics. The photoelectric effect demonstrated that light carries energy in particles, photons, which could release electrons from metals. This was a key step in the birth of quantum mechanics. In 1915, Einstein completed his general theory of relativity, which explained gravitational forces as the curvature of space and time, surpassing Newton's universal law of gravitation. The theory successfully explained phenomena such as the bending of sunlight by massive objects and was confirmed by observations during a solar eclipse in 1919. This validation made Einstein a global celebrity and a hero of science. One of the greatest challenges in Einstein's career came with the rise of the Nazi regime in Germany in 1933. As a Jew, Einstein was forced to flee Germany when Adolf Hitler came to power. The Nazi government dismissed Einstein's scientific work as Jewish science and targeted him. He first fled to Belgium, then to England, and finally to the United States, where he joined Princeton University's Institute for Advanced Study as a professor. In the US, Einstein not only continued his scientific research but also became a prominent advocate for peace. He vocally opposed the spread of fascism in Europe, but fears of Nazi Germany developing an atomic bomb plunged him into an internal conflict. In 1939, alongside other scientists, Einstein wrote a letter to US President Franklin D. Roosevelt urging the development of an atomic bomb, which led to the start of the Manhattan Project. However, Einstein regretted the creation of this weapon for the rest of his life. After World War II, Einstein actively campaigned against nuclear weapons. He spent the rest of his life working for a peaceful world. In 1946, he addressed the United Nations, advocating for the prohibition of nuclear weapons. He was also an outspoken opponent of racism, particularly condemning racial segregation in America, and stood in solidarity with African American activists. By 1955, Einstein's health had deteriorated. On April 18, 1955, he died at Princeton Hospital in New Jersey from a ruptured aortic aneurysm. However, events surrounding his brain after his death would spark significant ethical debates regarding his legacy in both scientific and moral terms. One of the most notable events following Einstein's death was the theft of his brain. Dr. Thomas Stoltz Harvey, the pathologist who performed the autopsy at Princeton Hospital, removed Einstein's brain without permission. Harvey intended to study it to uncover the biological basis of Einstein's intelligence, but this action created a major ethical dilemma, as he had not obtained consent from Einstein's family. Harvey dissected Einstein's brain into 240 pieces and distributed them to neurologists around the world for analysis. Some studies suggested that Einstein's parietal lobe showed unique differences. However, these findings were not enough to definitively explain the biological foundations of Einstein's genius. The question of whether Einstein's intelligence was due to brain structure or environmental and cultural factors remains unresolved. The theft of Einstein's brain brought ethical concerns in science to the forefront. Unauthorized removal and use of a person's body for research violated basic principles of medical ethics. Einstein, who had lived a humble life, would likely have disapproved of such an act, making this incident starkly contrary to his personal wishes. Albert Einstein was not only a revolutionary genius in the world of science but also a symbol of ethics, peace, and human rights. While his scientific discoveries had a profound impact, his contributions to humanity, including his commitment to peace, shaped his legacy. The controversy surrounding the theft of his brain after his death may have cast a shadow over his scientific legacy, but it also served as a reminder of the importance of maintaining ethical standards in science. Einstein's life, achievements, and the ethical debate around his brain's theft illustrate the critical balance between scientific curiosity and moral responsibility. His legacy endures not only through his groundbreaking scientific contributions but also through his lifelong fight for humanity. Published in 1905, the special theory of relativity is considered one of Einstein's most significant contributions to science. This theory provided a new framework for understanding how objects behave at speeds approaching the speed of light. Einstein's core claim was that the speed of light is constant throughout the universe, regardless of the object's motion or the observer. This challenged the classical concepts of absolute time and space proposed by Newton. According to special relativity, as an object's speed increases, time slows down and the object contracts. These phenomena have been confirmed through modern experiments with high-speed particles. For example, in particle accelerators, subatomic particles traveling at near light speeds experience time dilation, just as Einstein's theory predicted. This theory forms one of the foundational pillars of modern physics and today's technology. Einstein's famous equation, E=mc², also stems from this theory. The equation shows that mass can be converted into energy. Even a tiny amount of matter can produce a tremendous amount of energy. This concept laid the groundwork for nuclear fission and fusion technologies, including the development of atomic bombs. However, Einstein always expressed concern about the destructive use of his theory and voiced his deep moral concerns for humanity. In 1915, Einstein extended his work on special relativity to develop the general theory of relativity, which revolutionized the understanding of gravity. Unlike Newton, who described gravity as a force between two objects, Einstein explained it as the curvature of spacetime caused by mass. According to Einstein, massive objects warp spacetime, and other objects move along this curvature. One of the most famous predictions of this theory was that light from distant stars would be bent by the sun's gravitational field. This was confirmed during a solar eclipse in 1919, when astronomers observed that starlight was indeed bent by the sun, proving Einstein correct. This breakthrough catapulted him to international fame and confirmed the accuracy of general relativity. Today, the general theory of relativity is used in numerous technologies and astronomical observations. It plays a crucial role in understanding black holes and the expansion of the universe. Gravitational waves, first observed in 2015, were another prediction of Einstein's theory, once again proving its validity. Throughout his scientific career, Einstein had significant reservations about quantum mechanics, a theory that describes the behavior of subatomic particles. Although he contributed to its early development, the probabilistic nature of quantum mechanics conflicted with his belief in a deterministic universe. Einstein famously stated, "God does not play dice," in opposition to the randomness inherent in quantum theory. For Einstein, the universe operated under precise, predictable laws. One of his most famous challenges to quantum mechanics was the EPR paradox, Einstein-Podolsky-Rosen paradox, which critiqued the concept of quantum entanglement and argued that quantum mechanics was incomplete. Despite his objections, quantum mechanics continued to thrive and remains a cornerstone of modern physics. Phenomena like entanglement, which Einstein doubted, now serve as the foundation for quantum computing and quantum communication technologies. Einstein's skepticism of quantum mechanics highlighted his philosophical stance on science, even though many of his doubts were resolved by later developments in the field. Albert Einstein's personal life was as complex and eventful as his scientific career. His relationships, marriages, and family dynamics were marked by a mixture of passion, intellectual collaboration, and personal difficulties. Marriages and relationships. Einstein married twice. His first marriage was to Mileva Marek, a fellow student from his time at the Zurich Polytechnic. Marek was a brilliant physicist in her own right, and some historians suggest she contributed to some of Einstein's early work, though this remains a subject of debate. They married in 1903, and the couple had two sons, Hans Albert and Eduard, as well as a daughter, Liesel, who was born out of wedlock and whose fate is somewhat mysterious. Some reports suggest Liesel was given up for adoption, while others indicate she may have died in infancy. The relationship between Einstein and Marek eventually deteriorated. Einstein's intense focus on his work, combined with his growing fame, created tensions. Their marriage ended in 1919 after years of separation. Part of the divorce settlement included the agreement that Einstein would give Marek the Nobel Prize money, which he did in 1921 after receiving the award. Despite the personal turmoil, Marek played a significant role in Einstein's life during his formative scientific years, and their early collaboration has remained a subject of interest. Einstein's second marriage was to his cousin, Elsa Lowenthal, whom he married shortly after his divorce from Marek. Elsa, who had been a widow, took care of Einstein and managed much of his personal and domestic affairs. Their relationship was affectionate, and she supported him through the rise of his global fame, but it is widely known that Einstein was not a conventional or faithful husband. He had several romantic liaisons outside of his marriage, though Elsa chose to stay by his side. She passed away in 1936, and their marriage, though marked by Einstein's extramarital affairs, lasted until her death. Parenthood and family life. Einstein's relationship with his children was complicated. His eldest son, Hans Albert Einstein, followed in his father's scientific footsteps and became a prominent engineer. Though the two shared a scientific bond, their relationship was strained at times due to Einstein's absences during Hans Albert's childhood. Einstein's younger son, Eduard, was diagnosed with schizophrenia in early adulthood, which caused Einstein immense personal pain. Eduard spent much of his life in and out of psychiatric institutions, and Einstein rarely saw him after fleeing to the United States. The emotional distance between father and son weighed heavily on Einstein, particularly after the death of Mileva, who had cared for Eduard after their divorce. Einstein's personal letters reveal a more intimate side of him, where he expressed guilt, frustration, and sadness over his complicated family life. His focus on science often came at the cost of deep personal relationships. Still, he remained connected to his children, especially Hans Albert, who moved to the United States and maintained correspondence with his father until Einstein's death. Struggles with fame and identity. Einstein's rise to international fame in 1919 after the confirmation of his general theory of relativity turned him into a global celebrity almost overnight. This level of public attention was challenging for someone who valued privacy and introspection. As his scientific ideas became widely known, Einstein found himself caught between his role as a public figure and his desire for a quiet life of intellectual pursuit. In addition to the pressures of fame, Einstein struggled with his identity as a Jew in a world growing increasingly hostile toward Jews. Although he was not particularly religious, Einstein identified strongly with Jewish culture and later became a prominent voice advocating for Jewish rights, particularly after the rise of Nazi Germany. His flight from Germany in 1933, after being targeted by the Nazis, forced Einstein into a more public role as a political figure, advocating for both Zionism and the creation of a Jewish homeland in Palestine, though he hoped it would exist alongside peaceful relations with the Arab population. Einstein's pacifism was another defining aspect of his identity. Despite signing the letter to Roosevelt urging the development of the atomic bomb, Einstein was deeply regretful about his indirect involvement in the creation of such a destructive weapon. After World War II, he became a staunch advocate for nuclear disarmament and global peace, dedicating much of his later years to these causes. Einstein's legacy, intellectual, ethical, and cultural impact. Albert Einstein's legacy extends far beyond the scientific community. His intellectual contributions reshaped how we understand the universe, and his work has influenced countless fields, from quantum physics to cosmology. But Einstein's impact also includes his cultural influence and the ethical questions raised by his actions and ideas. Impact on science and technology. Einstein's work on relativity and quantum mechanics laid the groundwork for much of modern physics. His theories have been tested and confirmed through experiments involving atomic clocks, gravitational waves, and the detection of black holes. Technologies we take for granted today, like GPS systems, rely on corrections derived from Einstein's theory of general relativity, as the warping of spacetime due to Earth's gravity affects the synchronization of satellites. The discovery of gravitational waves in 2015 by the LIGO, Laser Interferometer Gravitational Wave Observatory, experiment was a stunning confirmation of one of Einstein's predictions from 1916. It demonstrated that ripples in spacetime caused by massive cosmic events, such as the collision of black holes, could be detected, further proving the robustness of general relativity. Einstein's equation E=mc² also paved the way for nuclear power and the development of atomic weapons, though this dual-use technology embodies both the potential and peril of scientific advancement. Einstein's legacy in this realm is bittersweet. While his work helped usher in the atomic age, he remained conflicted about the consequences of these advancements, particularly the destruction wrought by nuclear weapons. Philosophical and ethical contributions. Einstein was not just a physicist but also a philosopher who frequently engaged with the ethical implications of scientific discovery. He was known for his pacifism, humanism, and opposition to militarism. Throughout his life, Einstein voiced concern about the application of science for destructive purposes. His involvement in the atomic bomb project was a source of profound regret, and he spent his later years advocating for peace and the elimination of nuclear weapons. He also opposed racial segregation in the United States and spoke out against discrimination, lending his voice to the civil rights movement. His friendship with African American intellectuals like W.E.B. Du Bois and Paul Robeson demonstrated his commitment to social justice. Despite his theoretical work being grounded in the mysteries of the cosmos, Einstein was deeply connected to the pressing social issues of his time. Cultural icon and influence beyond science. Einstein's name has become synonymous with genius, a testament to his immense intellectual contributions. But beyond this, he has become a global cultural icon. His iconic appearance, marked by his untamed hair, pipe, and casual wardrobe, coupled with his quirky personality, made him a beloved figure in popular culture. His image appears on countless posters, memes, and products, cementing his place as a symbol of intelligence and eccentricity. The Einsteinian worldview, one that combines curiosity, skepticism, and a deep appreciation for the mysteries of nature, has influenced generations of thinkers. His famous declaration that imagination is more important than knowledge continues to inspire innovators across disciplines, from artists to engineers. Controversies and debates surrounding Einstein's life and legacy. Despite his extraordinary achievements, Einstein's life and legacy are not without controversy. Some of these debates focus on his scientific contributions, while others pertain to his personal life, ethical decisions, and even posthumous treatment. Collaboration with Mileva Maric. One of the most enduring debates surrounding Einstein is the extent of Mileva Maric's contribution to his early work. Some historians argue that Maric, being a physicist herself, may have played a significant role in developing the ideas that led to the Annus Mirabilis papers of 1905. This argument is largely based on letters exchanged between the two during their courtship, where Einstein refers to their joint work and discusses scientific ideas. However, there is no direct evidence that Maric co-authored any of Einstein's papers. Einstein's biographers and scholars remain divided on the issue. Some suggest that Maric's influence may have been limited to intellectual support, while others believe she contributed more substantively. This debate touches on broader themes of gender and recognition in the history of science, reflecting the challenges women have faced in gaining acknowledgement for their contributions. Einstein's role in the Manhattan Project. While Einstein did not directly participate in the Manhattan Project, his decision to sign the Einstein-Szilárd letter urging President Roosevelt to develop an atomic bomb remains one of the most debated aspects of his legacy. The letter was motivated by fear that Nazi Germany was working on similar technology, but the ultimate use of the atomic bomb on Hiroshima and Nagasaki left Einstein deeply troubled. Einstein's advocacy for peace in the post-war years was a direct response to the horrors of nuclear warfare. He often expressed regret for his involvement in the bomb's development, stating, "Had I known that the Germans would not succeed in developing an atomic bomb." Tension between scientific discovery and ethical responsibility, a theme that remains relevant in discussions of technological advancements today. The controversial treatment of Einstein's brain, as mentioned earlier, the unauthorized removal and subsequent study of